So we've looked at determining limiting reactants through kind of a particle model, and now we're going to focus on a reaction. It's the same reaction that we looked at before, and we always need the balanced equation to do any kind of stoichiometry. So this is hydrogen and oxygen reacting to form water. Same as we looked at in the last video. We got our 2 hydrogen diatomic plus the oxygen diatomic, producing 2 moles or 2 molecules of water. So on a larger scale, we're going to look now at these ratios as being mole ratios instead of being like a particle or molecular ratio. In each of the following, we just want to determine which is limiting and which is excess. Now, to be honest with you, sometimes you can do this in your head without even doing any work. And now on a test or quiz, they're going to ask you to justify your answer. Justifying your answer could mean a calculation, or maybe in some cases, it just means a sentence explanation. Let me get you started with a calculation. What's given to us in the problem is what we have. Somebody gave us 5 moles of hydrogen and 3 moles of oxygen. This is what I have. I'm going to make myself a little note. I have that. Well, we want to see, like, do we have enough? We got to worry about this ratio in the balanced equation. Will something run out? I don't know. It's a 2-to-1 mole ratio between hydrogen and oxygen. So if you want to go the calculation method, you pick one reactant, and it doesn't matter which. Pick either one. Let's say for kicks, I start with 5 moles of hydrogen. Okay, so I'd start 5 moles of hydrogen. And we're just going to do a little mole-to-mole stoichiometry. We're going to cancel moles of what we chose, the hydrogen, and we're just going to switch it to the other reactant. Essentially, what I want to do is figure out, do I have enough oxygen? How much do I need? How much do I have? So we're going to switch it from hydrogen to moles of oxygen. And then we just plug in the mole ratio from the balanced equation. 1 to 2. Oh my gosh, this is crazy math. 5 divided by 2 is a big fat 2.5 moles of oxygen. What's important about this number, I mean, I know you can all do the calculation. Like we can all take 5 divided by 2. I get it. But we have to understand what this number means. The important thing about this number is that it's the amount of oxygen that you need. Here's the amount of oxygen that I would need if I want to completely react 5 moles of hydrogen. You always need half as much oxygen if I look at that 2-to-1 ratio in the balanced equation. Oh, well now we just do a comparison. What do I need versus what do I have? I need 2.5 moles of oxygen. I have 3. I actually have a little extra. So guess what? We just found the excess reactant. So the oxygen will be my ER, my excess reactant. If you only have 2 reactants, then by process of elimination, the hydrogen must be my limiting reactant. Well, that's not so bad, huh? Here's the calculation option. We pick one reactant, set up a mole-mole switch to convert to moles of the other reactant. We're trying to find the limiting reactant. And then compare what you calculate, that's what you need, to what's given in the original problem, that's what you have. Oh, cool. If we have extra, that's the excess reactant, and the other one's limiting. Now the other option, I mean, you can really pick either reactant. So maybe I would have started with the 3 moles of oxygen. Now watch what happens. If I picked the oxygen, I would set up a little switch, cancel moles of oxygen, switch it to moles of hydrogen. The ratio in the equation is 2 to 1. I always need twice as much hydrogen. So Plug that in, I get a big fat 6. That's what I need. I need 6. Compare that to what you have. Oh, you see where this is going, right? We need 6, we only have 5. We don't have enough. That's your limiting reactant. When you use up those 5 moles of hydrogen, the reaction is going to stop. And so if I would have picked the oxygen and found that my hydrogen was the limiting reactant, then by process of elimination, oxygen is in excess. People get so good at this that they don't even need to do a calculation. If you can just look at the ratio, especially if it's like an easy 2-to-1 ratio, and just kind of by inspection say, okay, if I take my oxygen and double it, then that's the amount of hydrogen I need. I have 3 moles of oxygen. I would need 6 moles of hydrogen. Oh, if I look at the problem, I don't have that. And then all you do is write a sentence to justify your answer. Otherwise, I don't know, maybe you just guessed right. But you don't need calculations. Sometimes I do, but if it's an easy ratio, I don't always show math. And you would not need to do both of these. Only one is necessary. So part B, same reaction. Let's see what we got here. 0.62 moles of hydrogen and 0.25 moles of oxygen. So it looks like it could be crazy, but it's really not. You pick either one. 0.62 moles. Let's say I pick the hydrogen. I don't know. I'll pick the hydrogen. I'll cancel moles of what I picked, the hydrogen, and switch it to the other reactant, the oxygen. We plug in the ratio. It is 1 oxygen for every 2 hydrogen. So all I'm going to do is divide by 2. So, I mean, sometimes even though the numbers look kind of wacky, oh, this isn't super crazy. 0.31. That's moles of oxygen. That's the amount that I need. All right, cool. So then we just go back and compare that to what we have. What we have is what's given to you in the problem. I need 0.31. Here's what I have. I don't have enough. I only have 0.25. So once we use up that 0.25 moles of oxygen, the reaction will stop. I might have a little extra hydrogen, but I don't have sufficient oxygen to completely react the hydrogen. So in this one, I found the limiting. So then by process of elimination, hydrogen must be the excess. Cool. And again, let's say you would have picked the oxygen to start with. You can pick either reactant, and you don't have to do both. But if you would have picked the 0.25 moles of O2, then we'd cancel moles of oxygen, and we'd switch it to moles of hydrogen. We'd plug in the ratio. It was 2-to-1. We'd multiply by 2. 0.5 moles of hydrogen needed. Then I would just compare that to what I have from the original problem. I have extra. What do you know? We did it right. I only need 0.5. I have 0.6. 0.62. That's the excess. So the math is not difficult. I know we can like multiply and divide by 2, but you really have to understand what these numbers mean. That's why science is just better math. Like the numbers mean something. Okay, so these are simple, mole to mole, using the ratio from the balanced equation. If we peek at the other ones, let's see here. Let's look at these bad boys. Same equation. It's still the hydrogen-oxygen thing, So I don't know, maybe for kicks, I'll just write that down here so I don't forget. It was 2 hydrogen plus the oxygen forming 2 moles of water. All right, so there's my balanced equation. Same one. The only thing different here is that you're given grams instead of moles. Oh, man. But that's fine. In order to use the balanced equation, we need these original amounts in moles. So if you have grams, which is pretty common, in the lab we would have grams, we need to switch them to moles first, then we can compare using the ratio in the balanced equation. Okay, so I got to get these out of grams into moles. 1.89 grams of hydrogen, which is diatomic. We're going to set up our little proportion to cancel grams. We want moles. 1 mole of a diatomic does need to be multiplied by 2. If I look up hydrogen on the periodic table, it's about 1.01. So I'm going to use this as 2.02. And then we'll divide. Okay, so 1.89 by 2.02, a little less than a mole, maybe 0.936 moles of hydrogen. And then we do the same thing with the oxygen. 4.07 grams of diatomic oxygen. You want to cancel grams, put her in moles. Oxygen is right at 16 grams per mole, so I still need to double that. We're going to use 32.00. Oh, okay, this is going to be way smaller. So like 4.07 divided by 32. Oh, brother. 0.127 moles of oxygen. These aren't really your final answer. I mean, our final answer is going to be which is limiting and which is excess. But in general, when you calculate moles, just go with the number of sig figs in the original data. So if the original masses have 3, I just left 3 in my moles. Okay, so now here's kind of how I would do this one. To be honest with you, I probably wouldn't do any more calculation beyond this. You have to get the grams into moles so that we can compare using that 2-to-1 mole ratio from the balanced equation. But that is a pretty easy ratio to look at just by inspection. So I always need twice as much hydrogen as oxygen. So if I were to take this oxygen and compare it to my hydrogen, it's kind of like I want to multiply the oxygen by 2, and that'll tell me the amount of hydrogen that I need. Well, I don't even need to plug that in my calculator. I can tell you right now that there's no doubt in my mind that H2 hydrogen, excess reactant, way excess. So just by inspection, okay, so I kind of need to double the oxygen to figure out the amount of hydrogen needed. Like 0.127 times 2, at like 0.25-ish. It's not even close to 0.93. That 0.93 is well in excess. I don't even need to plug it in my calculator to know that. There is way more than twice as much hydrogen compared to the oxygen. I could also kind of do this vice versa. So if I were comparing hydrogen to oxygen, I always need half as much oxygen. So if I took the hydrogen and divided it by 2, I would get the amount of oxygen needed. Okay, so like 0.9 something divided by 2, I don't know, like 0.45 something. But I could tell you that it's still way more than the 0.127. Meaning that I will not have enough oxygen. I would need like 0.4 4, 5 something moles of oxygen. I don't even have close to that. I can tell just by inspection that I'm not going to have enough oxygen. The oxygen is my limiting reactant. Now, if you want, you can plug it in your calculator and you can set up the mole-mole stoichiometry. But I don't think you always need that if it's a pretty simple ratio. I mean, sometimes if the ratio is kind of funky, if it's like a 4 to 5 or, I don't know, like a 2 to 3, and the amounts that I have are kind of hard to estimate, then I'll probably plug it in my calculator. But these, there's no question. I have well above twice as much hydrogen, and I don't have anywhere near half as much oxygen. Boom, done. That's not so bad. All right, so at this point, if you want to try pausing the video, see if you can do part D on your own, and then after you pause, bring it back. Let's see if you're on the right track. Okay, let's try part D. Let's see if you're doing this. Okay, I have grams. I can't work with grams. Got to get them into moles. So we're going to take the 20.8 grams of hydrogen, diatomic, cancel grams, we want moles. 1 mole was about 2.02 grams because it's diatomic. So what are we, right around 10. Maybe like 10.3 moles of hydrogen. Then we take the 24.0 grams of oxygen. Cancel grams, we want moles. 1 mole has the mass on the periodic table, but it is double. 32. All right, so 24 divided by 32. 0.750, I suppose, moles of oxygen. Okay, so again, pretty simple ratio. So I usually try these without any further calculation. I definitely needed to do that. I had to get them into moles. But now if it's just like a 2-to-1 ratio, I could probably do this by inspection. Okay, so I need twice as much hydrogen as compared to my oxygen. So if I were to take this 0.75 times 2, then that would tell me the amount of hydrogen needed. I need twice as much hydrogen. Oh, please. 0.75 times 2 is like 1.5? We have way more than 1.5 moles of hydrogen. I have over 10 moles. No doubt in my mind. H2 excess. So I'm guessing by process of elimination that the oxygen is again my limiting reactant. And it is. So if I were to think the other direction, if I take hydrogen and divide by 2, I always need half as much oxygen. Well, like 10.3 divided by 2 is still around 5. I would need 5 moles of oxygen. I don't have that. I have nowhere near that amount. So if you don't have enough, then oxygen is your limiting reactant. Okay, so again, with easy ratios, and like these are obvious easy numbers, essentially what I was just calculating in my head was the fact that I would need about 1.5 moles of hydrogen, and I would need, 10 divided by, or 10.3 divided by 2, so maybe like 5.15 moles of oxygen. These are easy numbers, easy ratios. I could do that in my head. Then I could look and say, well, do I have that? These amounts here, what I just calculated, these are what I have. I took the original masses that were given, and I just switched them into moles. But if you're using the original given data, that's what you have. And then we can compare that to what we need. Okay, cool. So here's step one. Step one with these limiting reactant problems is just determining which is the limiting reactant. In the next video, we'll figure out why we need to learn about the limiting reactant and then what to do with it.